I previously did a palindrome video, but it was not using recursion, it was using a simple for loop. Got a request to make one with recursion, so that's exactly what we're going to do here. The first thing that we're going to do is create a class. So we have a public class palindrome right here. You can call it whatever you want. Inside of here, we're going to have our test, and the test is just passing something into our method. So we're going to take user input to see if a word is a palindrome. Remember, a palindrome word is a word that is the same when you read it forwards to backwards. So the kind of thought process I'm going to use when I go about this is that we're going to use recursion, right? And just like the for loop, we're going to have it so every time we go through this, we're dropping the first and the last. That way we continue to look at it. It obviously can only be palindrome if it's an even number, right? Or if it is greater than 1. So if it's a word like I, that's a palindrome itself. So we can have a check if it's greater than, or if the word length eventually is less than 2, it'll return. We'll get into this in a second because that's a little bit confusing there. But basically what we're doing, the thought process is we have a word and we are taking off the front and the back of the word. We're comparing them. If they are the same, it is currently a palindrome. We're going to keep comparing until we have nothing left to compare. If it's continuously a palindrome throughout the word, we return true. Otherwise, we return false. So again, this is our test case. We're just going to take some user input. So we need a scanner, of course. Scanner scan is equal to a new scanner where we take our system.in. This is just very simple user input right here that I can't seem to implement. So we have our scanner right here, system.in. We are going to store this input into string word. So we're going to say equal to scan.next. So we get whatever word we have in here. Now we want to store our result in a boolean. So boolean, we'll call this result, is equal to is, and this is where we make our method, palindrome. That's what we're calling it, palindrome, where we pass in our word like this. We can do whatever we want with this, you know, we could, the simplest way would be to print it out. So let's print this out so we can actually see what we're doing here. Now we don't have this method. What we can do is hover over it and click create method. It's a lazy way to do it. So it's going to return a boolean and it's a string word inside of here. It's very similar to my other video. So what we're going to do first is store the front. Int front is going to be equal to 0. And this is because we want the 0 index of our word. We'll get to this in a second. Int back is just going to be equal to the word dot length. So the length of the word minus 1. Because remember, length is 1 more than the number of indexes. And when we go through something, typically we're going to use indexes. Whenever we have recursion, we always need a base case. So this is basically the kind of header of the for loop. This is where and why it's going to stop. If you don't have something like this, it's just going to run on forever, like an infinite loop. So what is our base case? Well, remember we said if our base case is, if we get to a certain point where we can't compare anything anymore, then that is where we stop and where we're going to turn. So if our word.length, because remember, every single time we go through this recursively, we're going to take a little bit off our word. So if our word length is what? If it's 0, well, so equal to 0, this would be true, right? Because we could have even. But again, what if we only have one character? Okay, well then you could say less than or equal to 1. Or you could just say less than 2. So if our word length is less than 2, you're going to want to, spoiler alert, return true. So that is our base case for recursion. All recursion kind of works like this. You always have a base case. You typically have a base case. So the next thing that we're going to do is compare characters. So let's grab our characters, shall we? So we'll have a character, if I can spell it correctly, character, and we'll just call this character1 is equal to, and we're going to grab the actual first letter. We'll do word, because this is our string, dot char at, we're getting the very first char, so at index is 0. It's going to be the front. And I guess we could always just set this to 0. We'll try to make this a little bit more improved once we're done actually coding it. Just going through the thought process of it right here to make it simple. We also have C2, so the second character that we are creating here is equal to word.char at, and then we are getting the back and putting it in here. Now we could also just do the word length minus 1, just put it in here, but I'm just trying to demo really the thought process behind this. And this is going to be back, and we can end this line here. Now we want to compare our characters. We have an if statement. We're going to say if c1 dot toString. So we're converting this into a string because I'm going to use the .compare_to method here. So we convert this to a string, and that's okay because it's a character. We can do this. We're going to do .compare_to ignore case because palindrome doesn't care about casing, right? It's just front and back. We want it to be the same. We'll have c2.toString. And when we compare these, if it's a 0, it's going to skip over this because in this if statement, we're going to want to return the other one, which is false. So what this is saying is we compare these two. If it does not equal to 0, then we are going to return false. And we actually have a little bit of information. It's kind of hard to see, but again, not going too much in detail. Again, if we compare these two and it returns, this method returns something that does not equal to 0, that means it's not a palindrome. If it returns anything that's not equal to 0, we are just going to return false. So if it's not 0, it's not a palindrome. Now, if we do compare these two and it is equal to 0, we are just going to skip over this. And then when we skip over this, we're going to go to our recursive part. So in our recursive part, we haven't shrunk our word yet, so we'll shrink and pass in the word. We want to return, because we do have to return a boolean, our method, which is palindrome. Comes up, we can press enter. And then we're going to make a substring out of our current word to make it smaller. We'll do word.substring. We have our beginning index. We want to chop off the first one, so we're starting at index 1. We want to stop at our last one, so we're going to do word.length. So let's go ahead and run it. If you want to, you can put like a breakpoint here and go and debug it to see how it like really works and how it goes through its recursive thought. It's going to ask us to put something in. Well, it's not really going to ask it and put a prompt in, but let's put in test. We can see it returns false, right? Test is not a palindrome. Now, what if we put hi and then hi? Well, that's going to return true. Let's test our other case if we only have one thing in here. So if we press X, it returns true because it's a palindrome. Again, you can debug through this and walk through and see how it really works. But this is the logic for it. If you're doing this in a different language, that's okay, because you can find some online converter and convert this Java code into, I think, any code you would like. I know it works for Python and it should work for other ones. This should be very similar to C and C++ also, but this is just the general idea of how we would go about it, only syntax really changes. Now, a way we could possibly make this better is notice how front is only used right here. So instead of having this declared right here, if we want to make this a little bit simpler, we could just put 0 right here, the character at the 0th index. Back right here is used once here, and it's kind of used again here, a little bit redundantly. Why don't we use back here? So let's take out the back. We can take this out and put the back here. I just wanted to show this because we have to change this to 1. We can't start at 0. This one here, and this would be the back. But you can change that as long as you understand it, and that's how we go about solving for this is palindrome.